Now I want to move on to the design capabilities of Comosys. And I want to start off with the basic tab, the basic design tab, which is in the dialog box of all frame elements. If you double click on any element, we see this dialog box. And I want to quickly go over the basic parameters which are available over here so that basic understanding is achieved. So the first thing we see over here is check for lateral buckling. And this tells the program whether we want this particular element to be checked for lateral buckling. We can turn it on or off, depending on whether we want that or not. Now, this is an interesting flag over here, which means provides buckling support. So what this tells the program is whether this chosen element actually becomes a supporting member for other elements. So for example, if I were to choose this particular beam and double click it, and I say that this one does not provide buckling support, then the buckling lengths will be calculated as if this element does not exist. And these ones exist, but this one does not for the beam, for example. But if I were to open that back up, what that will tell the program is that this particular element will support the elements it's connecting to. So it's connecting to this beam and to that beam on the two sides. And therefore, it will provide buckling support for them. Now, this obviously depends on, maybe this is not a good example, but if we had, for example, girts over here or roof purlins, you might or might not want to include them as providers of buckling support for the column. In industrial buildings, it's very common for the girts to be removed temporarily for maintenance purposes and this and that. So although they do exist, but you might not want to consider them for your buckling support. Now, continuing with the tab, there's this thing called forced. What that tells the program is that you don't want this element to be designed by Comosys. You want to force this particular section. You don't want any optimization. Maybe there's an architectural requirement, maybe there's some other requirement, and you don't want to basically allow the automatic algorithms which work for design to act on this element. You can tell whether it's a rolled section or not, and that obviously can change the design. This is important. So for example, in columns, the columns might be braced in this direction, the main direction, or in the web direction, or they might not. And depending on whether they are braced or not, whether the structure is braced or not, you will turn on these checks. Here you have something called the design restriction, which I'll talk about in a second. More importantly, over here you have your design sections, which I'll talk about when I'm explaining the design procedure. This is the number of design points for each segment. So every element will be divided into segments. So even this beam, for example, it's a physical beam going from here to here, but it has lots of things connecting into it. So it's composed of many sections. And so we have section 1 over here, 2, 3, 4, 5. So what that number is telling the program is that each section will be further divided into 4 points, 4 design stations to do your design checks. There's something about a cantilever deflection check, which I'll talk about, and there's the ability to override your buckling lengths as well. So let me just close that, and we can continue with explaining what the design parameters. So now let's start with the buckling length calculations of elements, as that is really a very problematic area in most programs. And a lot of, if you actually input your structure according to the detailing requirements, then the programs really mess up when they have to calculate the buckling lengths. So what I've done is over here, I've divided this beam, this physical beam, into 3 parts because I want splices over here in the detailed model. But as far as the buckling length, I know, as far as the main direction, the entire length of the buckling of the beam should be used for buckling in the strong direction, and in the weak direction, obviously these ones will restrain the beam from buckling in the weak direction. So I want them to be considered as well. So we have over here, if we go to the analysis and design menu, we have something called the unbraced length. And this can be checked for both the 2 direction and the 3 direction, 2 being this axis and 3 being that axis. So if I were to press the unbraced length button and then hover over this beam, I'm expecting the entire length of the beam to be shown as unbraced. And for this side, I want these elements to basically restrain it. So let me go over press this button and go over this beam. And as you can see, if I'm hovering over that beam, despite the fact that it's limited, I've broken it, it's still showing the entire length of the beam as my unbraced length in the stronger direction. If I were to press the 3 button, which basically tells the program to now switch to the other side, it shows you can tell the green, the red, the green, the red. Those are alternating segments for the weak direction, and it's telling me that in the other direction there are restraining elements, and we've got 4 segments, and in each segment the buckling length will be the lengths of those green and red and green and red alternating segments. If I were to, for example, interrupt and come over this middle member and do the same thing again, once again you will see that when I hover over the middle member, that also is shown to be the entire length is shown in the stronger direction. And if I press 3, then we get these intermediate areas for the buckling lengths in the other direction because of the existence of these. Now we talked about this this feature called, let's go back to the design tab, and as we said, provides buckling support. So if I were to remove that for, let's say, this particular element, and this one now does not provide buckling support, and if I were to go to my unbraced length again, so this is the strong direction, and let's press 3 to see the weak direction, and you see that in the weak direction it has now skipped that element. It's telling me that there's a red portion in the beginning, then there's a larger green portion, and then there's the final red portion for that element. And this larger green portion has basically skipped over the element which was coming perpendicular to it, which would normally have supported it, but since we've turned it off, it's no longer supported. Now, another thing which I can do is, instead of doing this, I can leave this on. I can say it provides buckling support, but I go in and give it an axial release. Now, in this case, once again, if this element has an axial release, whether on the start or at the end, it doesn't really matter. It's not going to provide buckling support in the weak direction. So although I have that particular feature on, the one in the design tab, that it does provide buckling support, but my analysis constraints are different. And now, once again, if I were to go to my unbraced length command and go over this, for the stronger direction, we have the whole thing. And for the weak direction, once again, we see that the element has been omitted. Now let's talk about a column, for example. So let's select this column, and this column is going across 2 stories, but it's also extending into this 3rd story a bit. But with the point where it is ending, there is nothing to restrain it. It's just continuing to connect with the column over here. So if the program was to do, if there were any design sections over here in this region, the buckling length which needs to be taken for those is not just this little stub which is coming out, but it should be the entire segment all the way to this point until you get to these lateral supports for the other column. So if I were doing any design checks over here, my segment length should be this whole length all the way all the way to these restraining elements. Now, if I were to go to my unbraced length command and select this column, you can see that in the bottom area, which I just showed, the entire area has been painted red. That will be the segment length taken, although the column actually stops short of that. So this feature is extremely powerful, and what it allows you to do is to focus on your detailing as well. You can check your splice locations. You can model your columns and your beams according to the actual splices where you want them, and you can rest assured that you won't need to override the K factors and the buckling lengths and this and that, because they're really time consuming. And every time you run the analysis and and the section changes, if you have to go back and modify those factors, then that's really a big problem. In Comosys, the buckling lengths and the unbraced lengths are calculated very accurately, even if the element is composed of several parts, even if it falls into a segment where the element after that needs to be considered, as you just saw on the screen. And this is a really time-saving feature. And the same intelligence is available to you for the deflection checks as well. So it's not just the buckling checks. So for example, if Comosys was to check for the deflection of this element, it will know that even though I'm checking along the stations over here for this little stub, I will need to take this entire length into consideration. So let's say the deflection limits are L over 500. Then which L do we use if you're doing the design of this element? Do we take this L, or do we take this and this put together, or do we take it all the way? So once again, the same intelligence which we just saw for the buckling lengths is also available for the deflection check. Now you do have the option of actually going to your design tab and actually overriding the variables, the automatically found unbraced lengths around the 2 direction for each segment. So this if you want to override, for example, you could have several numbers entered. So you could say that for the first segment, the unbraced length is 3 meters, and for the second segment, it's 4.5 meters. For the third segment and onwards, it is 5.5 meters. So you can override just in case you want to do something different. But in most cases, you will not need to override, and that will be a huge advantage for you. And you can do the same for the effective length factors K22, K33. But once again, if your releases have been entered correctly and your buckling lengths are correct as well, then your K22 and K33 factors will also be calculated correctly. But you do have this option of overriding the result.